So today's topic is RIP protocol, Routing Information Protocol, RIP. So already we studied about static routing protocol as well as default routing protocol. Okay. So in static routing protocol, okay, we have some drawbacks available. Okay, to overcome this drawback, we have dynamic routing protocol. That's what we are going to discuss. So here, this is a normal setup, right? We are connecting with 3 router and the edge we are connecting with switch here, then PC. Okay, this is a normal setup. So we have connected with the PC here and also we configure the IP address for the router. For example, here, okay, this setup here, if you configure the IP address for the router, okay, what router will do? Router will take this IP address, convert into network address and store it in the routing table. Suppose in this router R1 router, you have been configured with IP address. So what is the IP address you configure here? 10.0.0.10 you configure with FA0.0. 20.0.0.10 you have configured with serial 1.0. Oh, router, what router will do? A router take this IP address, what are the IP address you configure? 10.0.0.10. Okay, the network address. It convert the IP address into network address and store it in the routing table. So we have 10.0.10 available. Similarly, 20.0.10 we configure. So routing table has 20.0.0.0. Okay, similarly, auto router has been configured with 20.0.20 and 30.0.10. So routing table will have 20 network and 30 network. Auto router is having configured with 30.0.20 and 40.0.10. What router will do? Router convert this IP address into network address and store it in the routing table. So our 3 router have 30 network as well as 40 network. Okay. Now R1 router has 2020, auto router has 2030, auto router has 3040. Clear? If you want to communicate from R1 router to 10 network, yes, I can able to communicate because it's available there in the routing table. So whoever available there in the routing table, I can reach. From R1 router, I can reach my 10 network. From R1 router, I can reach my 20 network. But from R1 router, I'm not able to reach my 30 network or 40 network. Why? Because it's not available there in the routing table. If it is available there, I can reach. If it is not available, I cannot reach the network. Okay, whoever available there, I can reach. So we configure, we configure with routing protocol. So what is the routing protocol available? We have multiple routing protocol available. Okay, so starting with the static routing protocol, default routing protocol, okay, and then dynamic routing protocol. Dynamic routing protocol again classified into IGP and EGP. IGP again classified into distance sector, hybrid and link state. EGP we have one protocol available called path vector protocol, that is BGP is available here. So far we studied about static routing protocol, default routing protocol. In static routing protocol and default routing protocol, we have some drawbacks available, right? So what is the protocol so far we completed? We completed with static routing protocol. We completed the default routing protocol. Okay, now we are going to discuss about RIP protocol, routing information protocol. So what is the drawback in static routing protocol? So we have a lot of drawbacks here in static routing protocol. So we can say it cannot support for large network, right? If I have 3 router available, I can configure static routing protocol. If I have 100 router available, it's very difficult to configure. Okay, it's very difficult because we cannot remember the next stop address. Next stop address is very important. Okay, otherwise packet will be forward to different network. Okay, so it's very difficult to configure for large network. And also, the admin should know the complete topology, how the routers are connected. One router, R1, how R1 router is connected to R2 router, how R2 router is connected to R1 router, R3 router, which interface is connected. Okay, everything admin should know. Otherwise, he will configure differently. Okay, the packet will not be forwarded properly. No fault tolerance. Okay, if I have only one link available, static routing protocol, if the link goes, wrong, something failed. Okay, so even though if I have alternate path available, I cannot forward the packet via alternate path because admin has to modify the path. He has to manually modify the path. That's called no fault tolerance here. Automatically it will not change at all. Manual intervention is required here. So infrastructure changes can be manually adjusted. Okay, it won't be automatically moved. We have to adjust manually. Admin has to adjust manually. To overcome this only, we are going for RIP protocol. So what RIP protocol will do? Okay, that's what we are going to study. So simple explanation for RIP protocol here. Okay. Suppose for example, okay, in RIP how RIP protocol will work here. See here in the routing table, okay, R1 router has 1020, right? R2 router has 2030, R2 router has 3040, right? RIP protocol, what will do, by every third second, it forward the routing information to its neighbor. That means what? So what are the information available in R1 router? Okay, every 30 seconds, it forward the information from R1 router to R2 router here. So what is the information coming to R2 router here? 10 network as well as, okay, 10 network as well as 20 network, right? So this information coming here, 10 as well as 20. So I can say 10 and 20 is coming to R2 router, 10 and 20 coming to R2 router. But R2 router already knows about 20 network, right? So which network is not missing here? 10 network. So R2 router learn about 10 network here. Okay, now R2 router 10, 20, 30, right? By next 30 seconds, what router will do? R2 router will do? It forward the information from here to here. Okay, so now what will happen? It's forwarding what are the information forwarding here? A 10 network is forwarding, 20 is forwarded here, 30 is forwarded here, right? So 10, 20, 30 forwarded to R3 router. Now R3 router, what R3 router will do? It already knows about 30 network, right? It does not knows about, okay, 10 and 20. So R3 router now learning, okay, here 10 network and 20 network. Now R3 router, this R3 router, right? R3 router having 10, 20, 30, 40. Now next 30 seconds, what router will do? R3 router will do? It forward the information to its neighbor by every 30 seconds. If it forwarded here, it forwarded 10, 20, 30, 40, right? So here 40 is missing. So this router knows about 40 network. Learn the 40 network here. Now this router, second R2 router, it has 10, 20, 30, 40, right? It's forwarding the information to R1 router here. R1 router knows about 10 and 20 only. Now it learning about 30 and 40. 30 and 40. So within few seconds, all the routers knows about all other network. Okay, this is the process of routing RIP routing protocol. Okay, complete network has been reaching automatically. That's what dynamically. That's called dynamic routing protocol. It comes under dynamic routing protocol. Okay, within so that all the router has been reaching other network, right? So that I can able to reach my from 10.10 to 10.1 network to 10.1 to 40 network. I can able to reach because all the routes are available here, right? I can able to forward the packet from 10.1 to 40.1. Clear? Okay. So apart from that, we have to study about the characteristic of RIP protocol. Very important. Characteristic of RIP protocol. RIP protocol is a distance vector protocol. Okay, in the chart itself we discussed, right? RIP protocol comes under distance vector protocol. It comes RIP comes under distance vector protocol. So RIP is a distance vector protocol. What is the meaning of distance vector? It based on distance. Vector means direction. So it based on distance as well as direction also. Okay, it based on distance and direction. Next thing, RIP protocol uses an algorithm name called Bellman-Ford algorithm. Okay, what is the meaning of Bellman-Ford here? Bellman and Ford, they developed the algorithm. Okay, so they name it as Bellman-Ford. Bellman-Ford algorithm. Okay, Bellman-Ford algorithm here. That's what here, Bellman-Ford algorithm. Okay, so if I have multiple paths available, how will find out the best path? RIP protocol, how will find out the best path here? So because they are saying best path can be calculated by using a metric called Hopwood, they are saying, right? How will you calculate the best path here? Okay. For example, if I have multiple paths available, we can take a scenario here. Okay. R1 router I am having, R2 router I am having here. Okay. So and also here also one router is available. Here also another two routers are available here. So now, okay, I want to forward the packet from source to destination. From here, I want to forward the packet from source to destination here. I can go this way, I can go here, I can go this way also, I can go. Okay. So I can forward the packet from source to destination. This is my source here. Source to destination. So there are different paths available, right? What are the paths available? I can assume here path A. Okay, this is nothing but path A here. So path A, here we have path B available here. path C, path A, path B, path C. So now I want to forward the packet from source to destination. So now which path I can choose here? We have three paths available, right? Which path I can choose? By default, we can see if I go over here this way. Okay, I can assume if you go over here, this path actually, okay, I can use only two routers. One, two. But if I go over here, this path actually, if it goes over this path here, I'm using three routers. If I go over this path, I'm using four routers to reach my destination. Okay, four routers to reach my destination. Now, tell me which is the best path right now for me. The best path I can assume here, it uses only two router, right? So we can say this is the best path. But RIP protocol, how we calculate the best path here? Best path can be calculated by using a metric called hop count. So what do you mean of hop count here? Suppose for example, this is the router. Okay. So this router here, when you cross the router, hop count is equal to 1. That means what? When you send a packet here, when you cross one router, hop count is equal to 1 here. Suppose if I have two paths available, okay, two routers are available here. When you forward the packet, what will happen here? Okay, it's crossing here. First path here, second router, right? It crosses two paths, two router, right? So hop count is equal to 2 here. Hop count is equal to 2 here. Okay, but when it comes to RIP protocol, if I forward the packet area this way, okay, hop count, how many hop count available? 1 here, 2 here. This path, 1, 2, 3. This path, 1, 2, 3, 4. Now, which is having the lowest hop count here? So this path is having the lowest hop count. So this is the best path. This is the way RIP protocol finding the best path. So best path can be calculated by using a metric called hop count. Hop count here. Best path can be calculated by using a metric called hop count. So this router having a lowest best path, lowest hop count. So this is your best path here. Okay, because it has the lowest hop count here. Whoever having the lowest hop count, that will be the best. So next point here, maximum hop count is 15. So that means what? So hop count here, maximum here in this network here, we goes up to 4, right? Still, how many router I can able to connect here? How many router I can able to connect? How many hop count I can able to have? If I go like this, 1, 2, 3, 4, 5 like this, maximum hop count, that means what? 15 only. Maximum hop count is 15. If I say maximum hop count is 15 here, how many routers are supported? 16 routers are supported here because source router also available, right? So it totally is supported 16 router. So when you go for RIP protocol, it support maximum of 16 router only. Okay, 15 hop count, but 16 routers. Okay, 15 hop count, 16 routers only it support. Okay. So when you go for small network, they can go for RIP protocol. Okay, path with the lowest hop count is best. We discussed path with the lowest hop count is best. Hop count means what? Number of routers to cross to reach the destination is called hop count. So already discussed about this one, right? Send routing update by every 30 second. Okay, so we already discussed, right? Whatever the network available, send the complete routing table, send the complete routing information. Whatever information available there in the network, send the complete routing information to its neighbor by every 30 second. Okay, so whatever information available, send the routing information by every 30 second. Okay, that is RIP functionality. So here you can say the update has been sent by every 30 second. Update has been sent by every 30 second. Update has been sent by every 30 second. Okay, so RIP protocol. So that all the all the routers knows about all other network, whatever available there in the topology. Okay, this is RIP protocol. So periodic update. What do you mean periodic? Every 30 second. That's called periodic. Every 30 second completely sending the routing update. Every 30 second completely sending the routing update. That's called as periodic update here. So periodic update. You can see here periodic update by every 30 seconds here. Apart from that, they're saying they are using a protocol. Okay, UDP protocol. It's using UDP protocol with a port number of 520. That's the protocol that are using here. Okay, it support equal cost load balancing. Okay, it support equal cost load balancing. Does not support unequal cost load balancing. Okay, what is the load balancing? Okay, what is the meaning of load balancing here? Suppose, okay, if I have multiple path available, or which path I need to forward the packet here? Okay, equal cost. Suppose this router available here, one more router, another router here, another router here, another router here. Okay, so what is mean equal cost here? Equal cost load balancing. So I am forward. I have here multiple packet available, multiple path available here. If I forward the packet via this path, actually, what will happen? Okay, it goes via this way also. There are multiple paths available, right? I can forward the packet via this way, or I can forward the packet via this way here, or I can forward the packet via this way. Okay, here, what is the hop count? Okay, when I cross the router, hop count is equal to 1 here, 2, 3. In this path, hop count is equal to 1, 2, and 3. In this path, hop count is equal to 1, 2, and 3. Now, we can see that all the paths having the equal cost. How the traffic will be forwarded here, sir? Because it support equal cost load balancing. So, if I send 5 paths here, if I send 5 packets, here, how the packet has been forwarded here? So, first packet has been forwarded via this way here. Okay, so you can see here, first 5 packets available. So, first packet has been forwarded via, okay, first path here. Second packet forwarded this path. Third packet forwarded this path. What about fourth packet here? It forwarded via first path. Why, sir? It operates using a round robin manner. Round robin. Okay, this concept is called round robin algorithm. This is round robin algorithm. So fifth packet here. Alternate. I can say first here, second, third, fourth, fifth. This is way RIP protocol works. Okay. Now, why is saying equal cost here? Because equal hop counts are available, right? Equal cost. So, RIP protocol support only equal cost load balancing. If there is equal path available, then only it support. Okay. Sir, I have one more path available, sir. Will it support or not? Okay. So, will it support or not? For example, here. Will it support or not? Or I can say this path. What about this path here? Sir, this path, whether it will support or not. 1, 2, 3, 4. 4 hop counts are available. Will it support or not? No. It does not support unequal cost load balancing. It supports only equal cost load balancing only. It does not support unequal cost load balancing. So here the hop count is 4, right? So it won't support that particular path here. Sir, I have one more path available like this. Okay, for example here. Okay, I have one more router available. Okay, so this hop count is also 4, sir. 3. Hop count is 3 here. Because 3 hop count available. 1, 2, 3. Will it support or not, sir? Will it support, right? It's equal cost load balancing, right? Yes, support. First path here, second path, third path, and fourth path, right? All are having hop count of 3. Will it support or not? Yes, will support, right? Because all are having same hop count here. Yes, support. Okay, one more path I'm writing here. Okay, this hop count is nothing but what? Okay, this also hop count is equal to 1, 2, 3. Will it support or not? No, will not support. Why, sir? Sir, maximum hop count is 4 only. It support equal cost. Maximum hop count is 4. Okay, it support multiple path, but maximum is 4. But admin, as admin, administrator, network engineer, they can extend up to 6 path. 6 hop count they can extend. By default, it won't support. By default, it don't support. It support only 4 path. By default, it support only 4 path. Maximum 4 path only. It does not support 5 path. But admin can extend. Admin can extend up to 6 path. It can extend up to 6 path. So it support equal cost load balancing. It does not support unequal cost load balancing. In equal cost itself, it support maximum of 4 path only. Admin can extend up to 6 path. Is it clear, everyone? Okay, very good. Okay, so operated using round robin manner. Round robin. So admin distance is 120. AD value is 120. Clear? Okay, good. So RIP, there are 2 versions available. Okay, what is the version available here? RIP version 1 as well as RIP version 2. There are 2 versions available. RIP version 1 as well as RIP version 2 available. Okay, version 1 and version 2. RIP version 1, RIP version 2 we can say. RIP version 1, RIP version 1, RIP version 2. So what is the difference between RIP version 1 and RIP version 2? Okay, RIP version 1 is a classful network. Okay, that means what? What do you mean classful? Does not include the subnetting information along with the routing update. While sending the routing update, it does not include the subnetting information. For example, in my network, so in the example, in my network here, I have been configured with RIP protocol. But in the RIP protocol, okay, 10 network has been configured with /25. /8 we can say, right? /8 means what? Okay, /8 is nothing but 255.0.0.0 here. Okay, here, okay, even though it's 20 network only, I have configured with /16 here. /16 means what? 255.255.0.0. So 40 network I have been configured with /24 here. /24 means what? 255.255.250. This is submask, right? Even though if I use submask here, class A, if I use class A network, this is RIP version 1, it won't accept this kind of subnetting information. It will go with only with default. Even though if you configure /16 also, it will forward the packet via default submask only. That is class /8 only. Okay, this is nothing but what? Classful network. It does not send the subnetting information along with the routing update. Okay, but RIP version 2, it support, okay, this one, subnetting. So it can say classless network. Classless. This is classful, another one is classless. Classful and classless. So classful and classless. Next thing, broadcast address. RIP version 1 uses broadcast address. Broadcast address means what? Like a one to all, right? That is broadcast. Okay, one to all is broadcast. It is a broadcast address. 255.255.255.255. Okay, that means what? So it forward the information, it forward the routing update by using the broadcast address. Okay, so that's what we can say. It is a broadcast address here. But when you go for RIP version 2, it uses multicast address. What is multicast here? 224.0.09. That is the multicast used in RIP version 2. Okay, but here version uses broadcast address here. So apart from that, RIP version 1, send version 1, receive any version here. Send version 1, receive any version. So what is meaning here? Send version 1, receive any version here. Okay, here I have been configured with R1 router has been configured with, okay, version 1 here. Okay, so here also I configure with version 1 here. Okay, RIP version 1, RIP version 1. Here I configured RIP version 1. All are I configured RIP version 1. RIP version 1, RIP version 1, RIP version. All the three routers has been configured with RIP version 1. What router will do, sir? So router send version 1. So what happened here is sending the version 1 here. Sending the version here. Version 1. Here also sending the version 1 here. Okay, sending the version, right? What are the update available? Sending the version 1. Well, receiving here, receiving the version 1 update and also receiving the, okay, version 1 update, both in. Send, okay, both in here. But I can assume here, if I configure here version 2, what will happen? If I configure here with version 2 here. Okay, version 2. Now what will happen here? Same thing. Whatever happened right now is same as happened here also. Sending version 1. Okay, I am forwarding version 1, right? Sending version 1 here. You can see here. Sending version 1 here. Sending version 1. Okay. Receiving version 1 as well as version 2 also. Receiving version 1 and version 2. It's accepted version 2 also. Okay. But if we configure version 2, what will happen, sir? Here I configure with version 2 here. Version 2. Here I configure with version 1. I configure with version 2. Right now, what will happen? So you can see here, definition. Okay, when you go for RF, okay, RF version 2, what will happen here? Router send version 2, but receive version 2 only. Okay, so here if I configure version 2 here, send version 2. That means here also version 2 has been forwarded here. Here also version 2 has been forwarded. But receive, okay, receive version 2 only. Receive version 2 only. What about this one, sir? Version 1. No. Okay, version 1 will not be received here. Okay, it will not be getting received here. Okay, it will not receive. So that's the functionality of RIP version 2. Send version 2. Okay, receive version, okay, send version 2, receive version 2 only, not version 1 at all. Okay, but when you go for version 1 here, send version 2, send version 1, receive any version. That means what? It accepts version 1 as also it accepts version 2 also. Okay, so these are the characteristics available there in the RIP protocol. Apart from that, RIP version 1 here is no authentication available in the RIP version 1. But here, when you go for RIP version 2, it has authentication available. There are two mode of authentication available here. One is called a plain text as well as, okay, another is nothing but MD5 authentication. Two authentication available. Plain text authentication and MD5 is nothing but message digest authentication available. Okay, these are the characteristic of RIP protocol. RIP version 1 does not support VLSM and route summarization, but RIP version 2 support VLSM and route summarization. VLSM nothing but variable length subnet mask. Okay, subnet mask has been, okay, vary in multiple network based on the requirement. Okay, so it support version 1 does not support the VLSM and some route summarization. Summarization means what? Combining many network into single network. That can be supported in version 2. It will not be supported in version 1. So these are the characteristic of version. Okay, we understood here class which are the protocols support classless or class, which are the protocols support class 1 and class 2. They differentiate here. Classful protocol. Okay, classful protocol has been RIP as well as IGRP. RIP version 1 and IGRP we can say. But classless protocol we can say RIP version 2. Okay, EAGRP, OSPF is classless network. Classful and classless. Which other protocol comes under distance sector protocol? RIP version 1, distance sector protocol version 1 and version 2 as well as IGRP protocol. So hybrid routing protocol, EAGRP. Link state routing protocol, OSPF. The chart is available there. You can see in the chart here. Okay, distance sector protocol, RIP and IGRP. Hybrid routing protocol, EAGRP. Distance sector protocol, OSPF. Okay, you should remember all the things which comes out here. We are going to study one by one protocol. So right now we discussed about RIP characters, right? Now, so how to configure? Very simple method to configure RIP protocol. Okay, how to configure? This is the command. First we will go with RIP version 1, then we will go with RIP version 2. Router RIP, network along with the network address. Okay, this is the syntax for RIP configuration. Router RIP, network along with the network address. So here in this topology diagram, okay, so I want to write the syntax here. Okay, the syntax here, router RIP, network along with the network address. Okay, this syntax. So now I want to configure RIP. First thing what we have to do, first thing, okay, if you have a topology diagram here, we have to design the topology diagram. After that, we need to configure the IP address. That's first method. After configuring the IP address only, configure the IP address, then you can give show IP route command. Okay, first you can design the network like this. Okay, all the topology like this. Then you can configure the IP address for each router. Okay, you can configure the IP address here, R1 router, R2 router, R3 router, you can configure the IP address. Then you can give show IP route command to review the routing table, whether routes are available there in the routing table or not. You have to do it. So, first thing what you are going to do, first thing setup. Okay, you are going to design a setup, right? Topology diagram. Okay, you can say topology diagram. First thing you have to go with the topology diagram here. First thing. Second option, what you are going to do after designing the topology diagram? So you are going to, okay, configure the IP address. IP address for all the router. Next thing you are going to do, what you are going to do here? Okay, check the routing table, whether routes are available or not. Okay, the routing table. How the command? What is the command? Check routing table, right? Routing table. What is the command to check the routing table? Show IP route command. We will see the routing table. After routes, after checking the routing table here, if you understood that the routes are available there in the routing table, then we can go and configure the RIP routing protocol. So what is the command for RIP routing protocol? Simple command. RIP, router RIP, network and network address. So, okay, what is meant by router RIP? We are enabling the RIP protocol. Router RIP command is nothing but you are enabling. enabling the RIP routing protocol. That is first step here. Second step, okay, network and network address. What you are doing here? You are advertising the network. You are advertising the network. Okay, network of network. You are advertising the network. Okay, that's the activity you are going to do. Okay, so here I am going to configure R1 router, right? So I'm going to configure R1 router. R1 router. Go to the R1 router config mode here. Okay, then I want to configure R1 router config mode here. Okay, router RIP. Okay, so you are going to configure a router RIP. So what is the command you are going to configure here? You are going to advertise the network, right? So what is the network we are not advertise here? Understood here. Directly connect the network. You are going to advertise whatever network available there in the routing table, that you are going to advertise. Understood here? You are not going to search for remote network. What is the network available there in the remotely 30 network or 40? You are not going to search anything. You are going to advertise whatever network available there in the routing table, right? So I can say here 10.0.0.0 network address only you are going to advertise, not the IP address. So okay, completed. Okay, 10.0.0 here. Another network is also available, right? So I can configure 20.0.0 network 20.0. Very simple thing. 10.0 20.0. Similarly, I can configure for R2 router also. When I want to configure for R2 router, what we need to configure here for R2? I want to configure for R2, right? So what we need to configure for R2 here? Same thing. Okay, R2. Just I'm changing here. If it is R2 router here, R2 router here, R2 router. Same thing. Router RIP. What is the network available? 20 and 30, right? I have to configure 20 network and 30 network here. Finish. What about auth router? Auth router, what is available there in the auth router here? Auth router, okay, like 30 and 40, right? I have to configure 30 and 40 here. Finish. Clear? If you configure, okay, within few seconds, all the routers are available there in the routing table. Okay. So this is configuration nothing but what? RIP version 1. Okay, if you want to configure RIP version 2, simply add version 2 here. Okay, how to add here? Version 2. This is a command. I told you, right? This is a command for configure RIP version 1. After configure, you can see the routing table. Version 2 here means what? RIP version. Simple thing. RIP version 2. You can just add version 2 here. Okay, so here you can add version 2. So for example, here you can add version 2. Okay, in all the configuration, you can add version 2 here. Version 2, that's all. This is RIP version 2. Here also. Okay, suppose for example, you configure with the network, right? Router RIP command you are applying, right? After that, you can add version 2 here. Finish, that's all. Here also you can add version 2. Here also you can add version 2. Finish, that's all. This is called version 2 here. Version 2. This is the way we can configure. Okay. Very simple, right? So we'll see how to configure. So how to configure RIP protocol? Okay, in Cisco Spectre we are going to configure. Okay. So I want to take 3 routers. Okay, which router model we are using here? 2620 router, R1 router, first router, R2 router, and R3 router. 3 router I want to take here. R1, R2, R3. Okay. Both end I want to connect with switch here. Okay, first switch here. Then PC. I'm going to connect PC here. First PC and second PC here. So open a router here. Power on the machine. NM4AS card and power on the machine. Okay. Open the router. So power off the machine. Okay. So power off. We have to do power off here. Power off here. Okay. NM4AS module. We have to add it. Okay. Power on the machine. Open the router. Click the router. Power off here. NM4AS module and power on the machine. Okay. Clear, right? So now we can connect the cable here. Where is the cable available? Click the cable. Automatically will go with automatic cable here. So click cable here. Connecting the cable here. Okay. So now notepad. There is a notepad available. I can use the output and note down the IP address. What is the IP address I'm going to configure? 10.0.0.10 here. This IP address I want to configure along the submask 255.0.0.0. Okay. Here I'm going to configure with 20 network. 20.0.10 here. So I want to configure with the 20.0.0.20. So here I am going to configure with 30.0.0.10 here. This end I want to configure 30.0.20. I am going to configure 40.0.10 here. Here 40.0.0.1 submask 255.0.0.0 and 40.0.0.10. Okay. Other end, this PC I want to configure with 10.0.0.1 here. Submask 255.10. Okay, clear, right? So now I want to configure the router. Okay, so go to my router here. Okay, one by one I want to configure. First command, no command. Okay, no clear. Then enable command. Okay, config T, global config mode. First thing I want to change the host name of the router here. Host name R1. That is the name of the router. Okay, so next thing I want to configure the IP address for the router. Okay, what is the command here? Okay, interface FA070 IP address. IP address here. What is the IP address available here? Okay, 10.0.0.10 here, 255.0.0.0. No shutdown command. Exit. Interface serial 150 IP address. So 20.0.0.10 here, 255.0.0.0. No shutdown command. Clock rate. We have to apply clock rate here. Clock rate 64,000. Finished. Exit. R1 router completed. We'll configure with R2 router. CLI here. First command, no command. Enable. So config T. Host name R2. So interface serial 150 IP address 20.0.0.20 here, 255.0.0.0. No shutdown command. Clock rate 64,000. Exit. Another interface serial 1/1 1/1 IP address. So 30.0.0.10 255.0.0.0. No shutdown command. Clock rate 64,000. Exit. Finished. Configuration for R2 router connect over here. I can configure R2 router 20.30.0.20 and 40.0.10. 30.0.20 for serial 150, 40.0.10 for F8050. This interface I need to configure. Okay, go to router here. No command. Enable. Config T. Interface host name I can configure host name also. Host name R3. Interface serial 150. IP address 30.0.0.20 255.0.0.0. No shutdown command. Clock rate 64,000 here. Exit. Interface FA070 IP address. So IP address 40.0.0.10 okay, 255.0.0.0. No shutdown command. No shutdown command. Finished. Configuration over. Okay. So now after first thing topology diagram has been designed, then IP address has been configured. Third step, we need to check the routing table. That's very important. We need to check the routing table. So R1 router, I am checking the routing table by giving show IP route command. R1 router should have 1020 network. Okay, you can see 1020 is available. What about R2 router? R2 router has show IP route command 2030. Yes. R2 router 3040. 3040. Yes. Or 3040. From R1 router, I can reach 10 and 20, right? Yes, you can check it actually. Ping 10.0.10, I can reach. So 20 also I can reach, right? Because it's both are available there in the routing table. 10 and 20 is available there in the routing, I can reach. But when I try to communicate with 30 network, it won't be able to communicate. Because why? Because it's not available there in the routing table. If it's not available there in the routing table, I cannot reach my 30 network. Similarly, if I try with 40 also, same thing only. If I try with 40 also, I cannot reach because it's not available there in the routing table. Okay, if I try with 40 network also, I cannot able to reach. Whoever available there in the routing table only, router can reach the particular network. Here, 30 network and 40 network is not available there in the routing table. Now, I am going to apply the routing protocol, RIP. So, config the router RIP, network. What is the network available here? 10.10.0.0.0 and network, okay, 20.0.0.0, 20 network. 10 network or 20 because 10 and 20 is available there in the routing table here. Same network only I am advertising, not the remote network. Okay. So R2 network, R2 router, okay, config T. What is the command here? Router, RIP, okay, network. So 20.0.0.0 network, so 30.0.0.0. Okay. Similarly, auth router. I'm going to configure auth router. So config the router RIP network. So 30.0.0.0 here, network 40.0.0.0. So configuration over. Okay, all the protocol has been configured with the routing protocol. Okay, routing information. Okay, routing protocol, RIP routing protocol. So if you want to check the routing table, okay. So what will happen here in the few seconds? Each router will send the routing table to its neighbor, right? Each router sends the routing table to its neighbor. Within few seconds, all the routers are available there in the network. We'll check it actually. So what is the same command I want to give here right now? Show IP route command. Show IP route command. If I give show IP route command, I can able to see 10, 20, 30, 40. Okay. So here C represents connected here. Connected. Connected here. R represents what? RIP protocol. Okay. Then we have all the networks available. 10, 20, 30 and 40 network available with a /8. /8 means what? Subnum mask. CA representation. /8 subnum mask. Both are directly connected, 10 and 20. But what about this one? RIP protocol 120/1. 120/2. What is the meaning here? 120 is nothing but what? Your AD value. We discussed that. AD value. 120 is AD value here. 120 is AD value. What is metric value here for this one path? 1 here. What is metric value for this path? 2 here. Why we are having 1 and 2 here? So if you want to reach from R1 router to 30 network, what is the hop count here? Only one router I am crossing, right? Hop count is equal to 1 here. If you want to reach my here, 40 network here, what is the hop count available? 1, 2. Hop count is equal to what? 2 here. That's what here I am having 2. From R1 router to reach my 40 network, hop count is equal to 2 here. Okay, sir, what about the hop count available there in the R2 router? Okay, suppose if I have R2 router, I want to check the hop count here from R2 router. For the R2 router, if you want to reach my 10 network, if you want to reach my 40 network, what will be the hop count here? We are crossing only one router, right? How many hop counts are available? 1. What about this one? Here also crossing only one router, right? Hop count is equal to 1 here. Can we check it? That also go to the router here. You can apply here show IP route command. If you apply show, you can see hop count is equal to 1 only. Okay, hop count is 1. So next this is nothing but your next hop address. Next hop. So next hop is available here, right? There is next hop address available. Next hop. Next jump address available. So apart from the timer, the 30 second I told you, right? It's running. Timer is running here. Every 30 seconds update is running here. Connected with exit interface. This is the exit interface. So in the routing table, what are the information available there in the routing table? The routing table, routing protocol information. Which protocol it belongs to? Network. Clear? Along with the CADR, submask information. Next hop address. Okay, exit interface. Then AD value as well as metric value also. These are the information available at the routing table. Okay, good. So if you want to reach your network from PC also will try. Okay, how to communicate. So I can try from PC also. Open a PC. Before that, I will try from here whether I can able to communicate with all the networks or not. Okay, 10 network I can communicate. 20 also I can communicate here. 30 also I can communicate. 40 also I can communicate. Because all the networks are available there in detail, I can communicate. If we try with PC, okay, I can assign the IP address for the PC, right? Go to the desktop here. Okay, I can assign the PC here. 10.0.0.1 here. 10.0.0.10. Okay, clear? So another PC, open a PC here, desktop, 40.0.0.1, 40.0.0.10. Finish. That's all. So when I try to communicate from first PC to last PC, what will happen? Open a PC here, go to command prompt. I want to try from first to last PC. So I know what is the IP address of my PC by giving a command ipconfig command. If I give ipconfig, I can say my IP address is nothing but 10.01. That is my IP address of the PC. I want to check the remote. I want to check the connectivity with the remote network, right? What is the command we can use? Ping command. Ping 40.0.0.1 here. Okay, you can see here first packet will get lost because of learning. Actually try to learn the address here. You should say it's getting lost. Remaining thing you can see here. Okay, communicating right, first PC to last PC. If I try it second time, okay, without loss it will forward the packet because it already learned the address, right? Without losing the packet, it forward the packet. So I can apply trace also. When I apply trace route command, tracing the path. Okay, tracing the path, how the packet is moving, tracing the path here. Yeah, how is the packet is moving here from this PC? The packet is moved to where? 10.0.0.10 here. Again, the packet is moving to 20.0.0.20. Here 30.0.20. Here 40.0.1. What is the hops address available here? So when I go here, where the packet is been forwarded, first thing it forwarded from 10.0.1 to 10.0.0.10 here. Then 20.0.0.20, 30.0.0.20, 40.0.0.1 here. We'll check it actually by giving trace command. Okay, from PC we can apply the trace command here. We'll try to check it actually. Trace RT. Trace RT. Okay, 40.0.0.1 here. 40.0.1. Okay. If you apply 40.0.1, what will happen? You can see the path available. 10.0.10, 20.0.20, 30.0.20, 40.0. Perfect, right? It's coming perfectly. Okay, very good. So this is the thing, but RIP protocol. Okay, so this is a configuration we completed. We check the connectivity also. Okay, one more command available for clearing the routing table. This command, clear IP route command, clear IP route start command will clear the routing table. Okay, show IP protocol. Yes, we can use the show IP protocol to view the routing protocol information also. So we'll check it. Show IP protocol command to check the routing table, routing protocol. So here in the router, show IP protocol. Show IP protocol here. So what are the information available? You can see here timers. 4 timers are available. Update timer, okay, invalid timer, hold down timer, and flash timer. 4 timers available in RIP protocol. So and also you can see every 30 seconds a route sending the routing update by 30 seconds. Okay. What is the next due of 50 seconds? You can see next due of 50 seconds showing, right? 1 second if I give, what is the next due showing? 20 seconds. Once if I give show IP protocol, okay, what is the, you can see here, so 13 seconds. What is the meaning? Next update, it comes within 30 seconds. Right now it's updated. Next update will be on next 30 seconds only. Okay, that is meaning here. I have configured RIP version 1, right? So you can see it says that send version 1, receive any version. So it will accept version 1 as well as version 2 also. Okay, apart from that, it supports maximum of 4 paths. Admin can extend up to 6 paths. AD value is nothing but 120. Okay, this is RIP protocol. Clear? So next thing, if I configure with version 2, what will happen? So I want to configure version 2 here. So same topology. If you want to copy the same, actually, just okay, drag it here. Okay, drag it here. Select this one. How I am selecting here? Click mouse, drag it here. Selecting this one. Go to edit, copy. Go to edit, paste. If I pasting here, you should not click anywhere. What we have to do? Just drag it down. Drag it down. So another topology is ready right now. Okay, same copy has ready right now. If you want to remove the RIP protocol here, RIP here, just enable command. So config T, no router RIP. I am removing the RIP protocol. Finish, the RIP has been removed. If you want to check the routing table, I can give show IP route command. I can see 10 and 20 is available there. Similarly, I can remove for another network also. Okay, here second router, no router RIP. Because I want to configure version 2. So config here, no router RIP. To remove the RIP here, third router, Go to configuration mode. No router RIP. So remove the RIP protocol. Now I want to configure with version 2 here. Quickly configure the version 2 here. Okay, what is the command for configuring? Same thing. Router RIP command, right? Router RIP version 2. Finish. That's all. Okay, network 10.0.0.0 and network 20.0.0. Only simple run. These three commands. Okay, four commands, right? Router RIP version 2, network address, network address. We need to configure. Show IP route command. So config T here. We'll go to router RIP version 2 here. Finished. Network address. Okay, 20.0.0.0, 30.0.0.0. Finished. That's all. Okay, auth router here. Config T. Already config T only, right? Router RIP version 2. Network address. What is the network address available? 30 dot, right? 30.0.0.0. Network 40.0.0. Finish. That's all. Okay. So if you check the routing table here, yes, all the routes are available. Show IP route command. You can see all routes are available here. Okay. So I can transfer the packet from one PC to another PC also. You can see here the PC to PC communicate actions happen here because all the networks are available, right? 40.0.0.1. Yes. Yes, I can communicate, right? If you apply the trace command also, yes, trace command also, it will forward the packet from 10.0.1 to 40.0.1. Finish. That's all here. Okay. But if you want to check the protocol information, what is the command for checking the protocol information? Show IP protocol. Okay, when you check the protocol information, what is the information you are saying here? Send version 2, receive version 2 only. Okay, send version 2, receive version 2 only. That's the effect here. Send version 2, receive version 2 only. Okay, so I want to see the update actually, sir. Okay, whether using broadcast address or multicast address, I want to see. So when you go for R1 router, okay, this is R1 router, right? So I want to apply a command called debug. Okay, iprip command. You should not apply this command in real time. Okay, debug. Okay, iprip debug iprip command. You should not apply this command in real time. What this command will do? It will capture the packet. What are the packet has been sending from my router? All the packet has been captured here. In real time, you should, if I apply this command, it will occupy complete bandwidth. Okay, so the bandwidth which has been used for particular purpose has been underutilized. So because of that, you should not apply this command in real time. Okay, so RIP. Okay, you guys here apply this command, right? So you can see I applied the debug RIP command, right? After that, what is the command getting here? What is the information I'm getting? Sending version 1 update to 255.255.255. That means what? It uses broadcast address. But when I go and check here in second router here, it uses multicast address. I told you, right? Multicast address. You can see that one. Debug IP RIP command. Debug IP command. It shows the multicast address. Okay, what is multicast address here? 224.0.0.9. Whether it's getting or not, you can see whether we are getting or not. Are we getting, right? Okay, this multicast. So we applied for debugging, right? If you want to stop the debug, you can apply u all command or u all, or even another command is nothing but undebug all. Both are same only. U all or undebug all. So stopping the debugging, u all or undebug all. Suppose update here, right? U all command. Just type u all command. It stop undebugging here. Okay. So we discussed about all the things here. Apart from that, okay, timers also available. So there are 4 timers available here. Okay, update timer, invalid timer, hold on timer, and flush timer. Okay, there is timer available. So update timer indicates how often the routing update has been sending out of the routing update here. That is called update timer. Invalid timer indicates how long the router will remain in the routing table before being marked as invalid. That's invalid timer here. Hold on timer is nothing but, okay, if new routes are coming, it will suppress the routes. Okay, it will hold. Indicate how long RIP will suppress the routes. Okay, next flush timer, it completely removes the routing update from the routing table. That's called flush timer here. Okay, update timer, invalid timer, hold on time, flush timer here. So this will discuss. Timer, if you want to change the timer, there is a command, router timer basic. Suppose for example, so I want to change the timer value, sir. Okay, what is the timer value available here? When you give show IP protocol, so timer value is nothing but update timer 30 seconds, invalid timer 100 seconds, hold on timer 100 seconds, 240 seconds available, right? If you want to change the timer, yes. Okay, what is the command? Router RIP protocol, timers basics, timers basics. This is the command. Here you can apply update timer, invalid timer, hold on timer, flush timer. Just changing the timer value. Okay. So if I apply this value, if I give show IP protocol once again, you can see the change in the timer here. You can see all the timer has been modified. Sir, I want to revert back. What I can do? Just give no command in front of it. So in the timer basic command available, right? In front of the timer basic command, you can apply no command. No command in front of it. No. Just removing the timer to get into original timer value. No, removed actually. If I give once again, if I give show IP protocol, I can see the default timers. This is the way I can change the timer also. Okay, good. So finally, we come to end. What is the drawback available in the RIP protocol? What is the drawback available in RIP protocol? This also we discussed debugging and right. What is the drawback? Any drawback available in RIP protocol? We have multiple drawbacks, right? What is the drawback? First drawback. What is the drawback? It's in complete routing update by every 30 seconds, right? So okay, that's very good, sir. Complete routing update has been sending by every 30 seconds. That is very good, right? But what is the drawback here? Sending the update here, it learned the node. Sending the update, learn the route. Okay. Now all the router having 10, 20, 30, 40, right? All the router having 10, 20, 30, 40 is available here. Yes, it's very good, sir. All the router having 10, 20, 30, 40. But what is the problem here? Any idea? What is the problem here? So after learning the routes also, after I learned the routes, right? Even though I've learned the routes also, it's a periodic update. What happened periodic update? Again send the routing table. Okay, again send the routing table from here to here, 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 here to here. Continuously sending. It occupies the bandwidth. Even though I know the route, continuously sending the routing update, right? 30 seconds. There's a drawback here. Okay. What is the other drawback? Hop count. What is the maximum hop count here? 15, right? 15 maximum. So it support only 16 router only. More than 16 router, it does not support at all. Another drawback. Okay, sir. Hop count is a drawback, sir. Why hop count is a drawback? Any idea? Why hop count is a drawback? Hop count itself is a drawback. Why? Any idea? Suppose, for example, okay, here, okay, this is the path available. Example we can take. This is the path available. Another path here, I am having another path here. Okay, this path having a bandwidth. This path having a bandwidth of 256 kbps. This path having a bandwidth of 1.54 Mbps speed. 1.54 Mbps speed here. Mbps. Here also, this path having a bandwidth of 1.54 Mbps speed. High speed bandwidth available. But when you go for RIP protocol, what will happen here? RIP protocol always works using hop count only, right? What is minimum hop count available here? 1 and 2 hop count here. But other path here, 1, 2 and 3 is the hop count here. When I download any music or any movie via this path, example I can take, it takes around 3 hours for downloading for movie. Okay, or we can say 3 hours for downloading. Here, this path, okay, here, when I download any movie via this path, it takes me 3 hours for me. But if I download any movie via this path, it takes 3 days for me. But RIP protocol, what happened here? RIP protocol use only this path. Why? Because it's based only on the hop count only. It based only on the hop count. Even though best path is available, high speed path is available, but RIP protocol won't choose high speed path, best path. It based only on the hop count. It does not consider bandwidth, does not consider the delay, does not consider the load, reliability, does not consider at all. It considers only the hop count. How many hops are available? That's what RIP is a drawback here. Clear? So you can see what is the drawback available in RIP protocol. So RIP protocol, bandwidth, more bandwidth utilization. Hop count, another drawback here. Okay, hop count is a drawback. It does not consider bandwidth. Then, okay, maximum hop count is 50. It does not it support only 16 router only. It does not support more than 16 router. Periodic update. Okay, that's our problem here. Slow convergence. Convergence means what? Okay, if I have 4 routers are available, all the routers knows about all other network. When you go for RIP protocol, it takes a lot of time. Okay, to learn about all the network. That's what slow convergence. So apart from that, it support equal cost load balancing only. It does not support unequal cost load balancing. So this much of drawback available there in the RIP protocol. Okay, these are the drawback available there in the RIP protocol here. Okay, clear? So thank you.